Okay, exponential growth functions. Yeah, I'm getting pretty pumped up about that. Um, Guys, you're going to remember we've talked about exponential functions and we've graphed them before, but we want to talk specifically now about growth functions. And this is when a number is increasing by a certain percent time and time again after a defined time. So you can see the one that I have up here right now. They have it at 15 years, okay? Now let's talk about this formula over here. You can see that, well, I'll tell you, C stands for the initial amount. So for this little sample problem, 3,708 would be the sample amount, okay? And then R stands for the rate that it's changing, okay? And in our case right here, it's 6.9%, okay? Now remember, whenever I put this into my formula over here, I'm going to have to put it as a decimal because I can never work with percent in my math problems, okay? And T is going to be in years. Since it said annual interest, that means I need to give my time in years, and they said 15 years. Okay? Now, you'll see that when I multiply C by the stuff that's in here, it's times 1 plus a rate. Now, it would normally be that 1 as a percent is 100%, right? And then the rate is 6.9%, okay? And so the C is increasing by 106.9%. But remember, I have to write this not as a percent but as a decimal. So I need to move my decimal point 2 places to 1.069. So I'm going to get to this stuff in just a second. But I wanted you to see that when the money's increasing, I get to keep all the money that I started with plus the money that they pay me for interest. Okay? And that happens every year, so it gets multiplied 15 times in this problem. So that's why we raise it. Repeated multiplication is written as an exponent. Okay? Repeated addition is written as a multiplication problem, but repeated multiplication is an exponent. So just a little simple problem here. X plus x is equal to 2x, but x times x is equal to x squared. Remember, repeated multiplication is an exponent. Oh, didn't mean to do that. We write that as an exponent. Okay, right? But repeated addition we write as multiplication, 2x's. All right, good. Now I can get rid of that. Okay, let's go ahead and see what happens with this problem. I'm going to plug it in. You're going to need your calculators, guys. You've got to have your scientific calculator, so just make it happen. Okay. Y is equal to the initial amount, which is 3,708, okay, times 1 plus 0.069. Remember, I've got to write that percent as a decimal when I put it in my problem. And it's 15 years, okay? Now, we're going to use PEMDAS, guys. First thing I do is simplify what's inside the parentheses, and I'm going to get 1.069 to the 15th. Then I'm going to deal with exponents, so I'm going to multiply. I'm going to use my calculator, and I'm going to raise 1.069 to the 15th. So I'm going to type in 1.069, and I'm going to hit my up arrow, which is diagonal from my 7. Or you may have a y to the x there, same thing. And then type in 15 and hit enter. And then this is the number that I get from the calculator. 1.069 to the 15th is equal to 2.72060,554. And then I'm going to multiply that times 3,708, and I'm going to get 10088.00534. But folks, remember, we're talking about money here, so I need to round to the nearest cent, 2 places behind the decimal point, and so I get $10,088.01. All right, because the 5 right there makes it go up 1. All right, good job. Let's see how this works in some of our examples today. Okay, guys.